Sir, 45.
No, 1 over 22, you know. They're close.
120.
Yeah. Yes. You're close to the answer, but it's not that.
1 over 24.
Guess, yeah, guess.
No, say 1 over 24. That I might do. 1 over 24.
All right, now let's try Tamara. 1 over 24 is correct.
So Tamara this, sir.
No, Tamara text, so I can answer to Tamara text. All right, very good. So it's 1 over 24. 1/24. So next question now. What if the angle was, let's say, 36 degrees? What fraction of the circumference would it be? If the angle of the sector was 36 degrees, right here. If the angle of the sector was 36 degrees, here. What fraction of the circumference would that be? Any ideas? Any answers yet? Now there's a method they can use now. There's a method they can use to determine the fraction of the circumference. Nope. 1 over 25, nope. All right, as you try to think some more about it, I just want to show you something. All right, so let us complete our circle right here. Now, this angle, as we know, is 90 degrees already. And this angle here, I believe it is 30 degrees. Let me see. And let me show you something. All right. Let's look at this. So if I have this, and I mark this out here. Kimberly, let's see that person, please. And I have a second one. And then I have the third. So 3 of this makes 190 degrees. That simply means that this angle is 30 degrees. All right. Now watch this now. Watch this now. Oh, good afternoon, Zidane Morgan. How are you doing? Good afternoon, Sister Morgan.
Afternoon, sir.
Okay. Welcome back to Holy Trinity. No, you have been at Holy Trinity. Sorry. Welcome back to class. You're not a visitor like our dear friend. 1/10. Tamara. Explain to the class how you get 1/10.
Yes, sir. 110, sir.
Tamara, explain to the class how you get 1/10. Come bright girl, explain to the class how you get 1/10. Tell the class what you did to get 1/10.
Sir, me can explain to you.
No, give Tamara a chance. You want
Sir,
a
no,
chance?
I guess mo guess it.
Seriously?
Yes, sir. Me da look on the 36 one, the 31. I'm gonna guess it.
Oh. All right.
There's some guy explain to you.
All right, explain for her then, no?
Sir, I
Yes.
divide 360 by 36.
You divide 360 by 36.
Yes, sir.
Okay, everybody heard that? Should divide 360 by 36. Okay. All right. And you get 10. Okay, fine. And that's 1/10. All right. Question now. What angle now do we have now? If this is 90 degrees and this is 30 degrees, what angle do we now have? What angle is being formed right here for this sector?
Sir, repeat, sir.
All right, can everybody see this?
Yes, sir.
My question, if this angle right here, if from right here to here is 90 degrees,
Yes,
and
sir.
from here to here is 30 degrees. So what's the complete angle right here? What's the complete angle?
Sir, 126.
126. You can add
Sir, wait, sir. Sir, the angle here is what, sir?
120. Thanks. All right. So,
Sir, 126 me get,
no,
sir.
no, 120. 30 plus 90 are 120. Where you
Ah.
left from?
Ah.
What's wrong with the earth people now? All right. So, if the angle of a sector now is 120, then what fraction of the circumference right here? What fraction of the complete circumference is this part? What fraction is it? Anybody? Does anybody have the answer?
Sir, repeat, sir.
I must repeat.
Yes, sir.
I am saying
Jump overboard.
this is a complete circumference going all the way around. What is that?
Yes, sir. That's the circumference.
Good. So, but this sector now, so we have our two radius and an arc. This sector now
More than half.
has 120 degrees as an angle.
Sir.
So I want to find out now what fraction of the circumference is the length of arc. What fraction of the circumference is the length of arc for this sector? That's what I want to find out. What fraction is it? Nobody? Yes?
Yeah, me, I guess. More than half. 376.
326? No.
So
She get
fraction.
1/3, sir.
Who said 1/3? Who said 1/3?
Ashley Joe.
Ashley Jones. The
And
answer is 1/3.
somebody else said to sir.
Who else said 1/3?
For Ashley.
Camila said before me for sure, sir.
Oh, she did. Okay. Okay. Congratulations, ma'am. I wonder what, and tomorrow say 1:30. All right, good.
Sir, sure I want to get 1/3, sir.
All right, explain to her I want to get 1/3. She needs to know. She needs to know.
We divide 126 from 360.
Divide 126. You say 126 for my board?
No, 120, sir. I'm gonna get 3.
Oh, you divide 360 by 120.
Yes, sir.
Okay. I get 3. Okay. All right. So question now. You see what is taking place right here?
Yes, sir.
You see what I go on?
Yes, sir.
All right. Now this angle here is this sector here is supposed to be 45 degrees. Good. 45 degrees. But here the joke to it now. If I put this in here, let's say I put this here, so good. Can anybody tell me what angle they think this is? This sector B.
Sir, 180.
No, this is not 180. No.
Sir, sir, put him up on it, sir.
Can't be 180.
190.
No, not 180 that. That's not 180.
Sir, I know how much, you know, sir. I know how much.
How much do you think it is? All right, so this, I'm going to double check and make sure. So this is 45. So it's go there, so double check it, yeah.
Sir, what I want here? The other one. But then
Which one that?
underneath this. Underneath this, so that one there.
Hold on, wait. 1 second. Looking for my pencil.
That look a small piece here, sir.
You mean this?
Yes, sir.
This is 30.
30,
90.
that, sir.
Yeah. So this now is, I think it's 45.
Sir, 150.
150?
Yes, sir.
150.
I'm a think.
You think? All right, we'll see. This is supposed to be 45 degrees though. All right, so we're sure that this is 45, right? Half of the 90, true? All right, so this is half of the 90. So we know what this is. We're going to put it onto our circle now. And I hope when them get phone cards paper and make phone things them, when I get the question them for do, make sure when I get the cards paper and try help get help on to solve the problem then. Just like what I'm doing here. We don't start doing anything yet, but this is the part that I was giving you guys problem. So I'm trying to help you now to see what a way you could do it. Right. Okay. So this is now 90, 30, 45. What is that angle equal to? What's the total angle equal to?
165.
165. All right. So what fraction then is 165? What fraction of the circumference what fraction of the circumference is the length of the arc of the full circle if the sector is 165 degrees? Talk to me now. Any answers? Any answers? Any answers yet? This one hardy. Yeah, man. I know. I know. Mhm. Anybody figure it out yet?
Sir,
Yes, go ahead.
2 over. Yeah. May I come, sir?
I wait for you.
Sir, 2 over 1.
2 over 1. That's not correct. Can't be 2 over 1. 2 over 1 is 2. That can't be correct.
Sir, 2.
2. No, sir, it must be 2. Fraction? No, sir. Yeah. Far from correct.
Sir, guess me, guess.
Guess no, guess. Oh, go on, guess.
Sir, make yourself answer me correct.
How that go? You're trying still, which is good.
Sir, make it.
What you get? All right. While you check, yeah, go ahead.
Get 1 over 11. 1 over 11.
1 over 11. No. 1 over 11
Sir,
not going to
me
work.
get 1 over 15.
Tamara get 1 over 15. Nah. Nope. Wait, 1 over 15. No, man, that not gonna work. 1 over 15 not gonna work. Huh? 1 over 15 not gonna work, you know.
165. It divided. It's all about 165. 165 right there, so sir. 165 over there, so sir.
Yeah, man. 100, yeah, this is 165. Yes. On John 65, you're correct, yeah. That means you have a problem with fractions. You have a problem with fractions. All right. Before going any further though, do you notice that each angle is a fraction of the angle of a full circle, right? Everybody observe that? Does everybody notice that? Does everybody notice that? Am I talking to myself? Hello? Am I talking to myself? Okay, Ashley. So I was saying that if you notice that each angle, like for example, the 90 degrees here, is a fraction of the entire circle, which is 360. So this is also a fraction of the entire circle. Good. So the question is then, what fraction of the entire circle is this? And we can find what fraction of the entire circle is this. It's the same fraction of the circumference. All right. I know you're bursting your brain a bit. Let me help you out a bit. Let me help you out a bit. I'll help you out a bit. Eh? All right. Remember, when you're writing a fraction, it's going to be 125 degrees over 360 degrees. But I want you guys, I'm going to show you guys, you ladies, something. I'm going to show you something. There's a pattern. How do you reduce a fraction to its simplest term? And you know? How do you reduce a fraction to its simplest term? Nobody knows that? Does anybody know how to reduce a fraction to its simplest term?
Yes, sir.
You know how to do it? I don't hear Ashley. Is that yes or no?
Yes, sir.
How do you reduce a fraction? All right. Okay, if that's the case, then could you reduce distance to its lowest term? 165 reduced to 165 over 160. What's the lowest term that you could write this fraction as?
I'm going to do it.
Okay.
What's term for right how much, sir?
Write that fraction's lowest term, 165 over 360.
Sir.
Go ahead.
Present, miss.
Go ahead, Kemisha. Kemisha, I'm listening. Go ahead.
Sir.
Uh-huh.
33 over 19.
No, that can't write. That can't write. Try again. That's wrong. Try again. Nobody discovered it, is it? All right. Let me help you now. When you're going to reduce a fraction in its lowest term, this is what you do. Reducing a fraction to its lowest term. So I've got to do a class on this.
Sir,
Yes. Check. Yeah, now listen.
33 over 20.
No, no, no. You want to find, you want to factorize the top number.
Sir, I got 11 over 24.
11 over how much?
24.
Okay, that's correct. Could you tell the class how you got the 11 over 24?
Sir, I use 5 to divide. I use 5 to go into 160 and 306. 165 and 360. And I got 33 for 160. For 360. 165 is 33. 5 going to 165 goes 33 times. 5 into 160 goes 72 times. And then we then find the factor of 33 and 72. So and I use 3 and got 11 over 24.
Okay, that's correct. So the answer is 11/24. All right. So before we go any further, let us put in that answer.
How much you get? 11 over how much, sir?
11 over 24.
24.
All right. Now, the fraction is very important. Good. Fraction is very important. Now, let's look at how we reduce fractions. That is very important. How we reduce fractions. That's that.
Sir, may I tell you something, sir?
Then 11 over 24.
That,
Factorize
sir.
it. Eh?
Not that, the one where the alpha and the Saturday. No. So them use right accounting so on the part. Sir, that. Yes.
See it there. All right. Now, for those persons who are not aware as to how Ashley got that answer, I'm going to give you an idea as to how that happened. Right? But before we go any further, I just want you guys to understand that it is the angle that determines the fraction of what fraction of the circumference is the length of the arc. Good. So if you want to find the length of an arc, it is good to identify the fraction. What fraction of the circumference is that length of the arc? Good. And that fraction we're going to use now to multiply against the circumference. And that would in fact give you the length of arc. Now, but let me show you something first. You have to know this information in order to manipulate different angles, like 165. Finish writing, Miss Langford. Miss Langford, you finish writing?
Yes, sir.
All right, so let us now go to a whiteboard. All right, now step one, you're basically going to find list a set of numbers that can go into the numerator without leaving a remainder. Good. Step 2, the same thing. List a set of number that can go into the denominator without leaving a remainder. Step 3, look for the highest number, which is in both step 1 and step 2. Step 1 and step 2. And step 4, use that highest number to divide both numerator and denominator. Make sure everybody writes these steps down. All right, everybody write those steps down quickly, please. Everybody write it down, please. All right, so I'm going to show you now how that works. Now, if based on what Ashley did, she started off with 5, but you could have factored out 165 by listeners. So the 1 can go into it, 2 can go into it. So start divide the numbers by other numbers, see which one going to without even a remainder. Let's say 3 can go into it. Let's say 3 can go into it. 165 divided by 3. Yes, a 3 can go into it 55 times. Can 4 go into it without leaving a remainder? No. 5, yes, 33 times. 6, no. 7, no. 8, no. 9, no. 10 will leave a remainder, so no. 11, yes, 15 times. Can 12 go in there without leaving a remainder? No. 13, no. 14, no. 15, yes, 11 times. 16, no. 17, no. 18, no. 19, no. And you keep looking for them until you find what is common to both the numerator and the denominator. Right? So you have to practice writing fractions in its lowest term. That is what we have been doing for this exercise thus far. Good. That's what we've been doing. Now, so in order to find the length of the arc, you first need to find the angle, as we said before, of the sector. Having found the angle of the sector, you're going to write it over 360 degrees because the sector is a fraction of the full circle. You can reduce this lowest term, and then you're going to use that lowest term now to multiply with the circumference of the circle to find the length of the arc. Simple as that. All right. So let's try an example. Everybody follow? Everybody following me? Everybody following me? But no answer.
Yes, sir.
Okay, thanks. All right. Now, the length of my radius, as I told the last class, is 13 centimeters. 13 centimeters. Good. And let's just put it on the Excel sheet for ease of calculation. All right, so we're going to be looking at finding the length of the arc now. Finding the length of the arc. Okay, so we're going to put this in the center. Okay, now to find the length of the arc, we need to have our angle. Well, let's put the fraction of the circumference, that is. Then we need to know what pi is. And we know what the radius is. And then our constant, which is 2. So we're multiplying everything. So this will be the length of arc at the end of it. All right. Now we are saying, let's start with the 90-degree one. It's a quarter of the circle. So we have a quarter here. Pi is, we can write it as 22/7. Let's use 3.14 for now. And our radius is 13. And our constant is 2. Because it's 2 pi r. Let us see now what our answer will work out to be. So we'll multiply that by this. I'll multiply that by this. I'll multiply that by this. Let's see. So 9/13. So the length of the arc is 9/13. Good. Units, or centimeters rather. 9/13 centimeters. So what I did, I first find out if the angle is 90 degrees. Michaela, Paula, where she come from? There are persons who have been dropping off. Michaela Powell. Where you come from? You the last in the bathroom? Yeah, you the last in the bathroom.
No, whenever I catch up at a time.
Oh, okay, I see. All right, man. School soon done. All right, so what we did first is to find the fraction of the circumference, and we use the angle to determine that. Good. We'll multiply it by pi by its radius and by the constant 2, and that gives us the length of the arc. Good. All right, let's look at what about if it was 45 degrees. 45 degrees. Using pi as 3.14. So 45 degrees is what? 1/8, right? And radius is same, 13, doesn't change. Constant is 2. Let's see now what's our length of arc. So our length of arc we're having here is 2, really. That can't be right. All right. Oh, that can't be right. So this is going to be equal to this times this times this times times this. Why am I getting 2? Something right here, so. Not supposed to get 2 right here, so. So 1/8 of 3.14. Let me double check that. Something is not right. So 3.14 times that would be 8 times 13 times 2. It will be 11.05. That would not be that. So this can be correct. This can be correct. Let's see if we put this as 22/7. We get the same answer. Just 3.14, 3.14. Point is 3.14. Something not right to the Excel calculation here. Not supposed to get 2. Something is not right with that Excel calculation. Not sure why we're getting 1/8. Not sure. Why are we getting 1/8? All right, something not right about this. So 1/8 of, we're gonna convert that 1/8 into decimal and see what we end up getting. So 0.125. So this is the answer here. 10.21. That's what the answer is, 10.21. And if we had written this as 0 into decimal, 0.25, 20.41. So recognize now that as the angle gets smaller, or the fractions get smaller, then length of arc will also get smaller. We're going to continue this in our other class. We're going to start from here in our other class. But just wanted to get the point that you can use the angle of the sector to determine the fraction of the circumference. When you get the fraction of the circumference, we're going to multiply it by the pi, the radius, and the constant, which is 2, and that will give you the length of the arc. Is that clear? Is that clear?
Yes,
Yeah?
sir.
All right, so what we're going to do for next class, everybody must get them circle. Everybody must get them cartridge paper, scissors. Good. So yeah, compass or if you don't, if you don't have a compass, get something round so you can draw a circle. Good. Get something round so you can draw your circle. Good. So if you get something round you can draw a circle with. They can fold it and fold it so we can get the different angles out of it. I want everybody to be practicing and you get it right. So we'll move from there. We all can find the length of the arc and also the area of the sector. So next class, please, everybody must get their the cartridge paper, something round to draw your circle, nothing small, something big. Good, maybe like a ear oil, something like that. Good, so you can draw your circle, you can cut it out, you can fold it, and when you start learning from it for each person. All right, I know you don't learn anything fully yet, but next class, everybody should be able to find the length of the arc, understand why we use a formula the way we use a formula, and then we move on from there. All right, let me mark the register now. And please to help me, because you know some persons have dropped off. So please to